Okay, fine. So, in the last session, we have been discussing about uh, the development of an application. How do we develop the application, and where do we develop the application, and what is that funnel we are going to create out of that application that we have seen. Let us try to understand again some more about it in this session. So, I said that yesterday. This is what we have discussed. This is somewhere the cluster running. The cluster is running somewhere in remote location, let us say, into some remote location. Okay, we don't see this where this running, it is running somewhere. And this is where we are, somewhere at our machine. We are using our machine here. Okay, so what we need to do from here is we must be able to access this. We must be able to access this. So here what we do here is we develop an application. We develop a Spark application. We develop an application. There is nothing but a Spark application we need to develop. For that, what are the tools required? SDF we have seen an IDE, a build tool like Maven or SBT that is required. IDE and a build tool. Okay, that's fine. Okay, this is where the cluster is running, and this is our machine, and here we have developed an application using this. Okay, now so after developing the application here, first we run it locally. First we run it locally here. Okay, here in this machine, just we run it locally in IDE itself. And if it is run, if it has run successfully, then we make that application to be ready to be deployed to the cluster. Okay, to be ready to be deployed to the cluster. Okay, now I will try to show you first in the beginning. Already yesterday we have developed an application, right? We have developed an application. We have tested it also. We have run it in the local mode, in local in this machine. It has run successfully. Now I will try to show you. So after this is, this has run successfully here. What are the changes to be made? To be deployed onto the cluster. Okay, I will show, and how to deploy that application to the cluster I will try to show you here. Okay, so what is the cluster we are assuming here? That is Hadoop cluster, that is HDFS and yarn. So in this cluster, HDFS is where we have the data, that is where data is available, and yarn we can do for use for processing. Okay, so this is for the Spark application has to read and write the data, okay, from HDFS, and it has to work on, it has to do the computation of data on yarn. Okay, so in that way we have to design the Spark application here. Okay, no? So develop an application, test it locally, is it working fine, then make some changes in the configuration so that it can be deployed to the cluster. So in the cluster, this is, it has to read from HDFS, it has to write to HDFS, it has to run on yarn. Okay, let me show you that part. Let us go to that application again. Let me show you that. Okay, this ID we have been using is IntelliJ. So in that the project that we have created, this is the project, Cloudera project 1. Let us open the project. Okay, this is the IDE that is open. Mm, it will try to update the project whenever we open. Every time it will try to update with any changes in the project. Will try to update it. You can see in the below it is showing that something like scanning files to index. So let's wait first. Let's wait for a few minutes. Till it gets updated. Okay, that's fine. This is a simple application yesterday we have developed. Okay, this application we've seen already yesterday. So we have run it yesterday in a local environment itself. So locally it has done successfully. Now what are the changes is we need to make this application to be deployed onto the cluster, isn't it? For that, what are the changes we need to do? Here change the master URL from local to 1 second, the system is slow. From local to 1 second, yarn client, from changes from local to yarn client. Okay, so we did not hard code the input path and output path. We shall give that input and output path to be read from hdfs. So this application has to read the data from hdfs and write to hdfs, and it has to run on yarn. So further, this is where we are making the changes here. Yarn hyphen client and args0 args1. Okay, so after doing all these changes, we need to create a jar file. Okay, let this process going on still going on. We can observe here in the bottom. Just wait for a few seconds. It won't take more than seconds. I think some download is going on. Let me stop it. Cancel the download. Okay, meanwhile, let us discuss something. It may take some time. No. Okay, this is what we shall see after that gets happens there, finishes there. No. So let's get into the programming. So that is done. Now the next thing that we are going to discuss is about Spark programming. That is Spark app development. We need to develop the Spark application. Further, we need to do the programming in Spark using Scala language. Using Scala language, Scala language API, we need to develop the Spark applications. Okay. So in order to understand the Spark programming, here we should know what the Spark contains, what type of programming we can do with Spark, and what type of data we can do with the process with Spark. All these we need to understand. Okay, so what type of data we are going to take it, and what type of data that we are going to process by the Spark, that we need to understand here. So in the yesterday session, we have been discussing from many sessions that since many sessions that a Spark application can read the data from HDFS, it can read from network file system, it can read from Amazon S3, it can read from MySQL, Oracle, this RDBMS, right? MySQL, Oracle, some Teradata, all these are MySQL, RDBMSs, and NoSQL databases like HBase, Cassandra, and MongoDB, and even from Hive also. Okay, so a Spark application can read the data. A Spark application can read and write the data. Okay, from any of the storage systems. It can be integrated and it can read and write the data from any of the storage systems. Okay, this is what. Okay, a Spark application can read and write the data from any of the storage systems. Now, here we need to be very cautious here. That is, now, if we talk about a file system, what will be the type of data in a file system? The data will be in the form of files simply. A file system is nothing but the data is stored in the form of a file system, sorry, in the form of files. So in NFS, NF is also a file system. Here also the data is stored in the form of files. In S3, the data is stored in the form of buckets. Even these are files only. Even these are files, but we call them as general, they are called as buckets. So the file systems, the storage systems, these are the three storage systems, that is nothing but file systems. So they maintain the data in the form of files. Now, when we come to RDBMS, the data is not stored in the form of files. The data is stored in the form of tables here, isn't it? So the data is stored in the form of tables. And when we come to this, what you call as NoSQL databases, even in this, the data is stored in the form of tables. And when we come to Hive, here also the data is stored in the form of tables again. Okay, so if we use a file system, the data is stored in the form of files. If we use a RDBMS or NoSQL database or Hive, the data is stored in the form of tables. Okay, so even it can be used integrated with the streaming components like Flume, Kafka also. Kafka also. So when we use Flume, the data is read in the form of events, and in Kafka the data is stored in the form of messages. Okay, so these are all the different storage systems are. These are not store. Flume is not a storage system, but Kafka is storage system. But general understand here, all these are different storage systems from where Spark can read from and write the data to. Okay, so the data is different formats. In HDFS, all these file systems, the data is in the form of files. In RDBMS, NoSQL databases, Hive, the data will be in the form of tables. Okay, so Spark application can pull the data from any of the storage systems. In this case, we must be able to understand how to read the data from, if it is a file system, how to read the data, how Spark has to read the data. If it is a RDBMS, how Spark has to read the data. If it is my NoSQL database, how Spark has to read the data. So this decision we have to make. Spark doesn't make the decision automatically. We need to make the decision and we need to develop the programming for it. Okay. Now coming to this, now when we come to files, what type of files can be there? Okay, let us come to first HDF or file systems. First, let us come to file systems. So, if we talk about file systems, HDFS or local file system, or it can be NFS network file system, or it can be Amazon S3, the data will be in the form of files and directories, that is folders. It can be, the data can be in files, or it can be directories, it can be some compressed files also. Okay, and what type of files can be there? Simply they can be some flat files, flat text files, that is text to flat text to files, flat text to files, or there may be some XML files, there can be some JSON files, some CSV files, some TSV files. So different types of files can be there. So how do we categorize all these files? Okay, and next, when we talk about RDBMS, that is something like, MySQL or Oracle or Teradata. Okay, MySQL, Oracle. In this, the data is in the form of what? Tables. And the NoSQL database also. In NoSQL also, the data is in the form of tables. And in Hive, also the data is in the form of tables. Okay, so here we don't have the data in the form of files. Here we have the data in the form of tables. Now we need to categorize all this data into certain categories or varieties of data. Generally we call them as varieties. Now generally the data is divided into three varieties. One variety is called as unstructured files, semi-structured files, sorry, unstructured files. Hive is not a database, Hive is a warehouse. Hive is not a database, Hive is a warehouse. Remember that it is a warehouse, it is not a database, it is a warehouse. So semi-structured and structured. So the data can be and we need to categorize the data into any of these formats: unstructured, semi-structured, or structured. So when we talk about tables, what is the structure of these tables? Whether it is structure, whether under which category they fall into, unstructured or semi-structured or structured. Okay, all these fall into the category of structured, right? Okay, so tables fall into the category of structures. Then what about these files? XML files, JSON files, CSV file, TSV files. Okay, all these files fall into the category of semi-structured. And simply we can flat text files and some audio files or some images, something like that. All they fall into what? Unstructured files, unstructured category. Okay, so it where we're reading from, when Spark reads from different file systems or RDBMS, this is what the type of variety of data can be. So if there are RDBMS or NoSQL or Hive, generally the data will be structured format. Okay, there is nothing but tables, nothing but the data is stored in the form of rows and table columns, so that will be a structured data as well. Okay, and generally XML files, JSON files, CSV, TSV files, all these files we treat them as what? Some structured files. And other files, like flat text files where we don't have any proper structure, we call them, we try to fall them into what? Unstructured category. So unstructured, semi-structured, and structured. So depending upon the structured, semi-structured, unstructured, we need to do the Spark programming here. We need to decide the type of Spark programming. Okay, we need to make the programming depending upon the file. Okay, now let me show you that. So if it is structured and semi-structured and unstructured, so these are the three different types of files, different types of files we can have when reading them from the storage systems. So now Spark has to, we need to first read the data. To read structured files, what is that object? Spark. Okay, Spark programming, I call it a Spark programming here. Spark programming. So if it is structured file, semi-structured or unstructured, here when we read the data into Spark, we need to load the data into some objects. Remember, in Spark, after reading the data from this, it can be file system, it can be any file system or any storage systems. It can be any storage system. So if it is structured, what unstructured, what it may be, the Spark has to create an object or create objects for storing the data that is read from the storage systems. It can be structured, semi-structured, unstructured. So what are the different objects that are used in Spark for storing the data? That is, we need to understand here. This is very, very important. So depending upon the type of files, there are three different data, the three different objects we can create in Spark programming. Okay, they are called as, the first initial object is called as RDD, the basic object is called as RDD. Another object is called as data frame, and another object is called as data set. Data frame, RDD, data frame, and data set. These are the three different objects that Spark uses for loading the data. Okay, for holding the data that is read from the storage systems. Okay, got it now? Right now, this is very, very important. What are these RDD, data frame, data sets are? These are the objects. These are the immutable objects. We have discussed in the Scala sessions about mutability and immutability of objects. Okay, so these are nothing but immutable objects. Immutable objects of Spark. Okay, they are called as RDD. RDD stands for resilient distributed data set. Resilient distributed data set. Okay, and this is data frame and data set. These are the three different objects which Spark uses for holding the data, for holding the data read from any storage system. Okay, so which object, Spark doesn't do it automatically, but Spark provides these three objects. We need to make a decision based on the type of data that we are reading. Okay, generally, if it is semi-structured or unstructured, we go with the data frame or data set. Okay, if it is semi-structured, unstructured, generally I'm telling you, this is what recommended we use. If the data is semi-structured or unstructured, it is recommended to go with, holding this data into in this loading this data as a data frame or a data set. If the data is structured, sorry, not sorry, I made this wrong here. This is not unstructured. Let me make this unstructured. Okay, if it is semi-structured and structured, use either data frame or data set. If it is unstructured, it is recommended to go with RDD. Okay, so if it is semi-structured or structured, so we have to make a decision that whether use either data frame or data set for loading the data or for holding the data here. And if the data is unstructured, then we go with RDD. Got it now? So depending upon the data whatever we have in the storage systems, and depending upon the format of data or variety of data, we need to create a particular object in Spark. Later we do operations on RDDs, data frames, and data sets. That's, we shall see later what operations we do on this RDD, data frame, and data set. But this is what first we need to understand very clearly about this. Remember, this is very, very important part. Okay, so let me summarize totally. After this, I will take some questions. So HDFS file systems. I say file systems and RDBMS. NoSQL databases and warehouse. So file systems, HDFS, it can be HDFS, it can be local file system, it can be S3, Amazon S3. RDBMS, they can be MySQL or Oracle or Teradata or Netezza. These are the different, RDBMS. Next, NoSQL databases like Cassandra and HBase and MongoDB. I'm just listing out the popular ones. Okay, and warehouse, the popular is one, Hive. So generally from all this, the data will be in the form of tables. Okay, and from this the data is in the form of files. These files can be semi-structured or unstructured. unstructured. Okay. Now, so semi-structured, unstructured. So tables will be always structured. We call them as structured data. Now here we have Spark. So we are developing a Spark application to read the data from RDBMS. Let us say some RDBMS. So from RDBMS, the data is in the form of tables. So in Spark we have RDD. Just now we have seen RDD. Another one is data frame. These are the objects which we use for holding the data after reading from the storage systems and data set. Okay, now, so we are developing a Spark application to read the data from RDBMS, some RDBMS. So the data in the form table. So which one use? RDD, data frame, or data set? I prefer to go with data frame. Okay, so all these tables, if you are the tables, generally try to go with what? Data frames, or we can choose data set also. Okay, data set. So structured data, the structured data go with this. And if it is semi-structured data, in that case also go with the data frames or data sets. If it is semi-structured data also go with data frames or data sets. If it is unstructured, go with RDDs. This is what we need to take a decision. Okay, this is what generally we follow. Okay, to read the data from the file systems. Is it clear? Okay, just if you have any questions in this, please let me know. I'm ready to take the questions, please. Any questions, please let me know. Yeah, Hina, Naveen, Rajesh, I think Kumaraswamy is there. Please let me know if there are any questions in this discussion. What have we discussed so far? If you have any questions, let me know. Otherwise, I will continue.
I'm good. You.
Yeah, clear. Okay. I think, are you hesitating to ask or anything? I don't understand. Feel free, okay? Don't hesitate to ask anything. If you're okay, just say me okay. Otherwise, uh, ask the questions. Is it okay, Naveen, from your side?
Yes, Karnataka.
Yeah, fine. Okay, that's fine. Hope everyone is fine with this. No. So let us come. This is the point, the basic thing we need to understand about before going to Spark programming. So if you don't have this, we may get confused. What is RDD? What is data frame? What is data set? When to use RDD? When to use data frame? When to use data set? We may run into some sort of confusion. So to avoid that confusion, I'm giving you this idea. Okay, this is about. Generally, we use only these file systems, RDBMS, NoSQL, warehouse, and somewhere we use what we call as streaming components. Streaming components like Flume, Kafka. This is different. This is totally streaming. There we use D streams. There we use Spark has one more data object that is called as D stream. That is restricted to only streaming. They are restricted to only streaming. For remaining all the storage systems, we use either RDD, data frame, or data set. Okay. Now I think that IDE is ready for us now. Okay, this IDE is ready now. So I made this change. We made this change, that is yarn hyphen client, and everything is fine. So what is this application is doing here? What is this RD1? This is called as, uh, we are reading a text file. When we're trying to read a text file, we create text file in the sense some flat file. So in that case we create RDD. This RD1 will be RDD. Just after we are reading data, doing some processing. What is the processing that we are doing? We are trying to create some output. So we are trying to get the data which get the records which contain only spark, and we are trying, finally we are loading the data or saving the writing the result to some storage system. So the storage system we are going to, here it is sdfs now, and the processing cluster we are going to we are using is going to use is yarn. Okay, let us now create a jar file for this. So for that, go to terminal, open terminal. Here, yes, here type sbt package. Okay, type here sbt package. It is going to create the package for it, that is jar file will be created for it. So we have developed an application here in IDE. We have tested it yesterday. It has run successfully. Now we are made the changes to be deployed to what you call as cluster. Now for that we are creating a jar file. So once the jar file is created, we submit the application to cluster. Okay. Now we will see how we submit the application to cluster. It will take few seconds. Hey. So meanwhile, yes, is done. Packaging is done now. Right. This is the path where we have this, this jar file. Let me that copy that path. Copy it. No, let me go to my file browser. Yes. Let me copy, paste the path here. Yes, this is the jar file. Okay, you can see the executable jar file. Copy this, and I'm just saving onto the desktop. Need not to be copied desktop, but for easy accessing, just I'm using copying into desktop. Need not to copy desktop. Okay, now jar file is ready for us, ready with us. Now application is ready, jar file is ready. Now we need to deploy the application to the cluster. Okay, so we are assuming this VMware as the cluster. This VMware Cloudera VMware has started already. So this VMware we are assuming at the cluster here. So we have to submit the application to this Cloudera. Okay, so now we can observe here cloud. We go to Cloudera. What is the, how do we communicate this actually we have here? Let me explain with that. This is important here. In my machine I'm using VMware, that is Cloudera CDH VMware image, VM image, and I'm using Windows. Have developed the application in Windows here in IDE using IDE. and I'm trying to deploy the application here. It is something like, this is our premises and this is the cluster. Okay, so I have to deploy the application to this cluster. So how do we have interaction with this? Is we should have a network. Without network, we cannot, what you call as communicate between these two. So we should have a network. So as we have in VMware, network will be established between generally this Windows environment and this VMware image environment. That's fine. So we need to know either host name or IP address of this to communicate with it. We need to know host name or IP address. So now we can go with IP address here. So we should know what is the IP address of this VMware image that is running here. Then we can submit the application from here to here. Okay, so that IP address is in my machine. The IP address is this one. So how do we see? How do we know the IP address here? Just go to that VMware, open the terminal, and type here ifconfig. When you type ifconfig, or you are going to see this IP address 172.16.38.160. This is the IP address. Okay, so now I'm coming out of it. I'm in Windows now. Now open command prompt. Open command prompt. Open command prompt, and don't worry about the path. What I'm where I'm going here. Spark-1. 1 second. Just don't worry what I'm doing here. Just only when I'm ask you to concentrate, then observe there only what I'm doing there, how that will be done. Now cd spark 1.6.2. Okay, remember this is where you need to concentrate here. Okay, so the script that is used from here command prompt, that is from Windows, we are submitting the application to VMware image. Okay, so what is the script that we use to submit the application to cluster? To yarn, we are submitting to yarn, that we have already specified in the application. Spark hyphen submit. Spark hyphen submit followed by space hyphen hyphen class. Okay, so what's the class here? It is the package name dot class name. So that what the package name and class name that we have used in the application, in the program, that is Spark program. Okay, we need to provide that class name and package name and class name. Happen to this, sorry, system has become slow today. Mhm. I think the class package name is com dot spark dot learning and sorry, something is happening in my machine. You can see here, this is the package name com.spark.learning, and this is the class name demo1. Okay, we need to provide those credentials here. Learning.demo1, sorry, demo1. After this, now after this we need to space followed by, we need to provide the jar file path. Okay, we have copied the jar file onto desktop, right? Just now we have copied jar file onto the desktop here. This is the jar file, so we need to copy the path of this jar file. So let us go to properties. There we'll find the path of this jar file, copy that and paste there. We get the path of the jar file. Okay, system is running slow today. Mm. Meanwhile, just let me enter the path manually. I know the path, c colon sorry, C colon double slash users. So use double slashes there. When you're submitting from Windows, use double slashes. Okay. Now go desktop, and the jar file name is it's loading very slowly today. Properties, loader project 1 underscore 2.10. Otherwise I have the jar file. Yes, we have jar file here. Let me copy the path of it. Let me copy its name. Sorry, this is running very slow today, my machine. It is behaving abnormally today. Let me just close this and open once again. Just a second. Yes. Spark hyphen submit hyphen class com dot spark dot learning package name dot class name demo1 followed by the jar file name users Karunakar desktop slash, and this is the copy it, and let me paste this here dot jar file. Close this. Right, this is the jar file, the jar path of the jar file, followed by we need to provide the input path and output path. We pass the argument 1 and argument 2 here. We can see here. Okay, we're passing argument 0, argument 1. We need to provide the input path as well as the output path. So where are we expecting the input and output now? So this Spark application has to read and write to HDFS of what? The cluster, of the cluster. Okay, of the cluster. So that is HDFS. So for that we give like HDFS colon double slash the host name or the IP address where this name node is running. Why? Because when we read from HDFS, we need to provide the credentials of the name node. So 1638.160. This is the IP address where the VMware is running, the where cluster is running. colon 8020 is the port number of the name node user Cloudera, and in this I have a file called as scala.txt. In this I have a file called as scala.txt. So this will act as the input. Okay, and the same HDFS 172.16.38.160 colon 8020 slash user Cloudera slash I say demo output. Okay, this is what I'm trying to show here. See this now. So this is the script that we have to use to submit the application to a cluster. That is a batch application or application to a cluster. That is spark-submit. There is a class name, that is package name dot class, and the path of the jar file followed by the input path and output path. Got it now? So just after this, submit the application, just hit enter. So when we hit enter, what should happen now here? The data has to be read from HDFS from here, and it has to be returned to HDFS. Okay, are you able to understand this one? So it has to read from HDFS, it has to write to HDFS. That's what has to be done here. So how do we verify whether data is returned to HDFS or not? Just let us verify here. In VMware, I'm trying to verify whether we have input data and whether there is output data or not. Let us verify before submitting the application. After submitting the application, we shall verify whether data is written or not. New file has to be created, data has to be returned to HDFS. You have to verify that also. So let us see that. Systems are stuck in system is stuck today. It's not working properly. It's working fine. It's not responding today properly. Let us just run the application, submit the application. Let us, we shall see later. Just hit enter, the application is going to start. See what happens and how the application will be submitted and how it will run. Just let me close this IntelliJ for now. After the application runs, let us open it again. Why? Because of memory issues, they are running into, the system is running slowly today. Let me close it. Fine. It has started running now. Sorry guys, sorry for the session. Today I'm running into some memory issues.
Not a problem, sir.
Let me close this and give once again. Close this, it is becoming very slow. Let me submit. Let me start the command prompt once again. Right, like what we can. SET. Don't worry about this. This for some client setup. Don't worry about all this. No, first concentrate from here. Spark hyphen submit hyphen hyphen class package name com.spark.learning dot demo one, and after this provide the path of the jar file. Do this is the path in my machine and desktop. Sorry, desktop. I have copied onto desktop and the jar file path. This is the jar file and the name of the jar file. Copy it and give the jar file dot jar. Okay, after this input path is dfs colon double slash 172.16.38.160 colon 8020 slash user slash cloudera slash scala dot txt. This is the input file path, and hdfs unit output is also I'm loading it into hdfs 172.16.38.160 colon 8020 slash user slash cloudera slash let me call this demo output. Now hit enter. This has to work now. So now this application we are submitting from Windows. I'm telling you from Windows to where? To VMware. So the services are running HDFS, YARN, everything, all services are running in the VMware, not here. Okay, but we are submitting the application from here to that VMware. That's something like cluster. We are assuming that as a cluster, as we have only one machine, but we are a one node cluster. Generally this application deployment will be done like this only. From I will tell you once this is the successful. I will tell you what is that. This is called submitting application in real time or in production. Generally we just submit like this by using spark-submit script only. Meanwhile, just let me explain what this is actually. Just understand here. Mm, okay, this cluster, you know, where Spark is reading data and writing data and working and processing data, that is on yarn, reading and writing from HDFS and running on yarn, and from here we are submitting the application. Generally in real time in production, generally this is called as a client or edge node. They call this with a name called as edge node or gateway node. Edge node or gateway node. Okay, so everything, cluster, directly we cannot access the machines of the cluster. So that is the reason a machine will be used, a node will be used in between the external world, between the external world and to the cluster. Okay, this is some external world and this is the cluster side. So in between it acts as an interface, it acts as a gateway. So that is the reason it is called as a gateway node or edge node. Okay, so from this actually we will be, even the people will deploy everything to the cluster, they work with the cluster by interact with only with what, edge node only, they do everything from this node only. So this acts as a gateway node or edge node. So all the scripts, submission, applications of submission of the applications, and reading the data from HDFS, writing the data to HDFS, everything will be done from everything from this client or edge node. They call it, some people call client, edge node or gateway node. Okay, so as we don't have that, now we are taking this as Windows. This Windows we are considering it as some gateway node or client, and this VMware image we are considering it as what, this clusters. Okay, that is what we are trying to understand. That now we are trying to simulate the thing, simulate the real-time scenario by using this. So assume like this. Okay, assume this is as a client and this as a cluster. Okay, we don't have many machines, only one machine, so one image and one client here. So we need to make this Windows machine, Windows operating system, as a client. So how to set up the, how to make this Windows as a client so that we can submit the applications, we can submit the application to this VMware. We don't go to this VMware, everything we operate from here only. We don't open this VMware from now onwards, remember. Only for specialized, changes or some modifications to the cluster, some kind of installations of new things are there, uninstallation of some components, we go to this VMware directly. But we don't do nothing directly get into this VMware. We do everything from Windows only. So we have to make this Windows, as a client or an edge node. So how do we make it, that we'll discuss maybe in the next session, but everything we do from this Windows only. Okay, got it now? Let us see if this happened or not. It is started. Yes, we can use putty also. Yes, we can use putty also. I will try to show putty also now after this is done. Okay, as she said now, now how can we connect? If you want to directly connect to this cluster, we don't have direct access to this cluster, but how do we make a connection to it? We can use putty here. We can use putty and putty. Some people call it as putty. I pronounce it as putty. So they use putty to make a connection to it. Okay, I will show you that also, how we can make a connection to it. So instead of directly getting into it, we use putty here. uh, Let me show you that if it works fine. Let me open this putty also here. It is taking too long today, some memory issues are running here. So this is the putty opened, let it run in the background, don't worry about this. Now putty here, and enter the host name or IP address. I am using the IP address 38.160 and open. So port is to 22, SSH, through SSH protocol I'm connecting to it. Open. So if we will be given a username and password, so we need to log in with those credentials, username and password. So for the Cloudera image, the default username and password will be Cloudera. Both username and password will be Cloudera only. So just let me maximize the screen. Let me increase the font size also. Parents. ఏదో జరుగుతుంది ఈరోజు. Nothing is working today. I'm getting into serious issues today. No? That's the number.